All right, so share screen. All right, so there's some things that we're going to cover, but before we get into it, and anyone can just chime in. Which one is longer? Is it 1 meter or 1 yard longer?
Yard.
Yard.
So we got a yard. Anybody think a meter's longer? Okay, the second one, how many centimeters in an inch? Honestly, I would be really surprised if somebody knew that off the top of their head. It's not something that is typically known. So we'll cover that. Which one's farther? 1 mile or 1 kilometer?
Mile.
Mile.
Mile? Good. And which one's warmer, 100 degrees Fahrenheit or 100 degrees Celsius?
100 degrees Fahrenheit.
Fahrenheit.
Yeah, Fahrenheit.
Celsius.
So it looks like we have some on each on that one. All right, so we'll get into that one as well. To start with, oops. All right, which one's longer, a meter, a yard? The meter is longer. So this is basically, 2 meter sticks. So this is 1 meter to the very end. And how many inches are in 1 yard? Anyone? It's on this lower one somewhere.
34. Or,
Almost.
in a yard.
36.
Yeah, 36.
36.
36
okay.
inches in a yard. So there's a few inches difference. I happen to have my pocket meter stick here. Just kidding, I didn't have it in my pocket. So the end of this is 1 meter. And if I flip this over, we have inches. So the yard is there. So it's, about that much difference, which, it's a little bit. Now I played several sports, but I ran track in college, and in track and field, early 1900s and things like that, they measured everything in yards. So they had, the 100-yard dash, or, the 400-yard dash, or 800-yard run, that sort of thing. Now everything's metric. So you can't directly compare times because they're different distances. If we have, this much of a distance or a difference between a meter and a yard, well, this isn't that much, but if you multiply it by 100, it's a pretty good distance, or by 400 or 800. Now it's getting to be a big thing. So there are some formulas that people use to try to compare like modern times with times that were recorded, when they were running in yards. But so it's kind of a little difference there. The meter is longer. How many centimeters in an inch is 2.54? Like I said, I would have been shocked if anybody would have just rattled that off. It's not really a common thing that many people use. In fact, now, if anyone needs to convert anything, you pull up an app that does conversions, or Google it or whatever, and there are 16,000 websites or something that convert units. So as you can see, 1 inch here on the bottom lines up to about 2.5 centimeters. Which is farther, the mile or kilometer? The mile is much further than a kilometer. And if anyone's heard of like a 5K run or 5K walk or something, like the the polar bear run that's up here every year at North Central, it's 5K, 5 kilometers. 5 kilometers equals 3.1 miles. Or all sorts of like cancer walks and things like that are usually like 5Ks, 5 kilometers. So like I said, that equals 3.1 miles. Because the mile is longer. All right. As far as which one is warmer, 100 degrees Fahrenheit or 100 degrees Celsius, 100 degrees Celsius is much, much warmer. Does anybody know the kind of the special thing that happens at 100 degrees Celsius?
No.
Hopefully it never happens to us, but it happens to water sometimes.
Evaporates?
Boils.
It boils, good. 100 degrees Celsius, water boils. So if water boils at 100, what does water do at 0 degrees Celsius?
It freezes.
Freezes, good. So that's kind of an example of how nice and neat the metric system is. Water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. Compared to Fahrenheit, which we use here in the United States, which I think the US and maybe one other country uses all the English imperial system or units like pounds and miles and gallons and all that stuff in Fahrenheit. What's the freezing point of water in Fahrenheit? Anyone?
-20.
32 degrees.
Yeah, 32 degrees. You can kind of see, if you're over here with 0 degrees Celsius, you can kind of follow that over, and it's, about 32. So 32 degrees Fahrenheit and water freezes. Does anybody know what temperature water boils at in Fahrenheit? It's a weird one. Anyone? No one?
12.
Yeah, 212 degrees.
Oh.
So again, metric system, you're at 0 and 100. Fahrenheit, you're at 32 and 212. Metric system just a lot easier to work with. That's just an example of it. Right. Metric system is kind of, it's a general thing. The word metric just means to measure. So in the word metric can be used by itself. If somebody's talking about different things that people are using to measure something, you talk about what metrics are being used to measure that, or the term biometric. So bio meaning life. So it's basically measuring life, measuring different things about life, like watches and like Apple Watches and Fitbits and things like that. They record all kinds of biometric data, heart rate. They track sleep. I think what the newest Apple Watch can take like an EKG or something to measure your heart rhythm, all kinds of stuff. So that would be biometric data. It's measuring different things of life. Metric system it's an international system of measurement and units. Like I said, pretty much every other country on Earth uses it except us. But as far as science is concerned, science uses the metric system, even here in the US. Because anytime there's collaboration between scientists, they want to make sure that they're on the same page with things. Plus, you don't want to have to convert values, going from English system to metric and back and forth, and it just makes everything easier. And the real beauty of the metric system is that it's based on 10. So it's, it's all tens or multiples thereof, into hundreds, thousands, 10,000s, and so on. So it lets you move and convert between units really easily because it's just a matter of moving decimal points one way or the other. So it's super simple to work with once you get it down. So it's really nice as compared to, our system, which can be a little confusing. All right, so if we're talking about length in the metric system, measuring distances between 2 points, be it something really close together or really small to great distances, we're using the meter. That's going to be the main unit. From that, especially if we're talking about large distances, we're going to use kilometers. but it's still meter. It's just adding that kilo prefix, which means 1,000. So if I had 1,000 meter sticks and I set them end to end, that would be 1 kilometer. So there's 1,000 meters in 1 kilometer. Now, if you go the other way to make it smaller, you could put a prefix like centi, which means 100th. So on the meter stick, there are 100 centimeters in a meter. So centimeter is 100th of a meter, or milli is 1,000th, because there are 1,000 millimeters in a meter. So it's that main unit is just changed up a little bit with the prefixes. For meter, lowercase m, you use meter stick, ruler, tape measure, whatever, laser, measuring device, whatever it is. But it's, like I said, it's much easier than miles, which is 5,280 feet. That sort of thing. It's just not easy to work with. Mass. All right, so if we're talking about mass, we're talking about the amount of matter, the amount of stuff that's in something. Unit that we use for that is gram. And again, if it's something large, we'll add a kilo on the front of that for kilogram. Kilo meaning 1,000. And that tells us that a kilogram is made up of 1,000 grams. If you kind of want to go the other direction, we have like a milligram, which is really small. Where would you be pretty likely to hear milligram used in regards to what? Anyone?
Medicine.
Good. Medicine is the biggest one that people are probably familiar with. So, if you have a headache or whatever, and you take, you grab a bottle of Advil, and it has 250 milligrams of ibuprofen. So within that pill, there are 250 milligrams of active ingredient. And milligrams are really small. I mean, like grain of sand kind of small. So kind of, fun fact or whatever, most pills and stuff that you take, most of it is not medicine. Most of it is just filler material to make it bigger. Because, depending on the dose, it might be, a grain of sand worth of medicine or smaller, which that's going to be really hard to keep track of. So they add in other stuff and basically like flour or like plant cellulose, and then they just make it bigger so it's easier to work with and easier to handle and all that stuff. Another place you might hear milligrams is like nutritional values, like the amount of salt or the amount of sodium or, whatever vitamins and minerals in whatever food products. You guys can look at the cereal box and see it all down the sides. So with mass, we use grams, symbol G, lowercase g. We use balancer scales, typically digital now, not so much manual anymore. Mass is also confused with weight a lot of times. They're similar, but they are different. Mass measuring the amount of stuff that there is, but weight is a measure of gravity pulling on that stuff. So an example to kind of separate those two, on the moon, the gravitational pull is less than it is here because the moon is smaller than the Earth. So if you have an astronaut and let's say they weigh 150 pounds or whatever on Earth, if you take that astronaut in the scale, the same scale to the moon, they're going to weigh less, but the mass is going to be the same. There's still the same amount of astronaut, but they're going to weigh less on the moon. So it kind of shows the difference. Mass, even though they're both measured with a scale, or they both can be measured with a scale, they're not the same thing exactly. if you're trying to find the mass of something that's solid, that's easy. You just use a scale. Try and find the mass of a liquid that's not as cooperative and would kind of run all over the place. Then you need to put it in something. So the way you'd find the mass of the liquid itself is you would find the mass of whatever container you're putting it in, and then you would put the water or liquid into that container, and you find the mass of the whole thing, and then you would subtract the mass of the container from that, and then that gives you the mass of the water. And pretty standard there. But that just makes it easy because, like I said, water is going to go all over the place, and you need to put it in something to contain it. Area. Hopefully we're all at least a little familiar with this. The amount of surface on something. So we will talk about surface area later on. I can't remember if that's first or second semester. When we talk about weathering and erosion, we'll talk about the surface area. So how much surface is exposed to the environment. Because the more surface area there is, the faster things break down, the faster things weather. Kind of a classic example of area is like a floor. If you need to get new carpet or tiles or something, you need to figure out how many you need. So you need to find the area of that floor. So it's just length times width. So if we're using meters, you have a length in meters, you have a width in meters, so you end up with meters squared. So it's a square meter is what you end up with. You figure out how many of those you need. And again, meter stick, ruler, tape measure, whatever, to measure those out. But the big thing is that it's whatever unit you're using, it's squared for area. Volume, and I don't mean loud volume. So volume is just how much space something takes up. So you can kind of think of your lungs. You have a lung volume. When your lungs are full of air and your chest expands, you take up more space than when you let the air out. You take up less space. You're changing the volume. Or if you blow up a balloon, you're changing the volume of the balloon because it's expanding and taking up more space or less space. The unit we use is liter. That's a metric unit for volume. Just like if you go to the store and buy a 2 liter or whatever, that's 2 liters worth of liquid. Capital L, we can also, again, switch that up. Milliliter, milli, again, being 1,000th. So on this graduated cylinder, it's marked off in milliliters. So if you had 1,000 milliliters, then that equals 1 liter, 1,000. If you're measuring on a graduated cylinder, we measure at the bottom of this curve that's formed. That's called the meniscus. The reason it forms is because the water is attracted to the glass. So it wants to stick to the glass. So it pulls up a little bit and it creates that curvature. And like I said, that's called the meniscus. And you always measure from the bottom. Has anybody ever heard the term meniscus related to anything else? Like sports or anatomy or anything? Anyone?
Sports.
Do you know where the meniscus is?
I forgot. Ain't it like, knee or leg? Or am I tripping?
Exactly. So if this is your knee joint, and this is like your shin,
Yeah.
your lower leg, create a curved space that your femur sits in, so your knee can move, and your meniscus is right in there. It's that curved space. It's the exact same word because it's the same shape. It has a curve. So sometimes people injure their knees, and they'll either tear their meniscus or bruise it or something like that. But again, that comes from that curvature, just like we see on that water. And measure volume, use graduated cylinder, which is one of these little guys. Whenever we do get back to school and you're using one of these, one of the big things with this is when you're measuring is you have to be on the same level. Your eyes need to be on the same level as the top of the liquid. Because if you're looking down on it, your measurement is going to be off. It's going to be different than if you're looking straight on it. So if it's sitting on a table, you have to like squat down so you're eye level with it to keep things precise. All right, so graduated cylinder, beaker, ruler, whatever is measured or marked off. What would be the volume measurement for this one? Anyone?
35. 35.
Any guesses?
36.5.
Excellent, 36.5. So again, we're at the very bottom of the meniscus. So here we're 35, 36, 37. So it's above 36, below 37, just right in the middle. So 36.5, excellent. All right. So the other type of volume that's kind of a solid, of a, I don't know, like a convenient solid, like something like a box that has nice edges and corners and things like that, is just length times width times height. That's all it is. So it's just like area, just with another step on there. So if I were wanting to, since I've already done my calculation to do new flooring in here in the classroom, let's say I wanted to turn the classroom into a pool and have pool parties every day. Then I would need to figure out the volume based on how deep I wanted the water. So then I would take my area value and then I would just multiply it by the height of however much water I wanted in here. And then I could order that much water and have them bring it in and pump it into the classroom. And then I could have pool parties all the time. I don't think I'll do that though. That's, but units are cubed for volume because again, you have, a unit for each measurement. So you still have, you can't get rid of those. So you end up with a cubic, whatever, cubic centimeter, cubic meter, whatever. If you're trying to find the volume of something that has a strange shape, something that's not easily measured, it is possible. And you've all done this. You just didn't realize you did it. The way you find this volume is by something called water displacement. So say you have a bathtub that's filled with water, hopefully not filled to the top. It has water in it. You get in the bathtub and the water level rises. That's because your body has displaced water. It's moved it from where it was because the water in your body can't take up the same space at the same time. So it moves that water out. You've displaced that water. To find the volume of something with a strange shape, like in this little illustration, like a rock or something like that, you put some water in a graduated cylinder and you record that value, and then you put in whatever it is, and it will displace the water a certain amount. Then you record that value, and then you subtract the original value from the value afterwards, after you put the object in the water, and that will give you the volume of that object. Even though it's, it could be shaped whatever, it'll give you the volume based on water displacement. So like I said, everybody's done this, they just don't realize it. Or when I was in college, I had a friend who was an athletic training major. And for a class, he had to do a bunch of biometric tests. And one of them was like a body fat percentage test. And a really accurate way to do that, one part of it is find the volume of whoever it is. So like I said, I volunteered to help him out. So I had to basically just get in a tank of water and exhale as much air as possible. So I took up as little space as possible and then stayed underwater for as long as I could to let the water, stop moving so they could get an accurate reading of how much water I had displaced so they could calculate my volume, because it's not, easy to measure, a human body as far as calculating the volume. So you use water displacement. All right, and then the last one, temperature. Temperature is just the measure of relative heat that's in something, and everything has heat in it. Even things that are super, super cold, they still have heat, they just don't have very much. And then obviously other things have a lot of heat. But for the metric system, we use Celsius, which has the symbol of degrees Celsius. We use a thermometer. We're all familiar with Fahrenheit because we live in the US, we're familiar with Fahrenheit. Yeah, and we kind of already talked about temperature a little bit. There are some other scales that aren't used nearly as much. Like if anyone's had ICP or chemistry, you probably heard Kelvin is another temperature scale. It's really only used in science. That's about it. So yeah, does anybody have any questions, or are there any slides I need to pop back to really quickly? No? Okay, I'm gonna stop sharing this. Back to it.